Hey everybody, today you're going to be performing the Center of Mass Lab. It's a lot to leave for you guys virtually, but I definitely know you can do it. In the front of the classroom, there's a whole bunch of cardboard little systems that have different shapes, and some of them have multiple layers where they have different masses of 2m and m, or some of them have 3m. And what you're going to be doing is figuring out the location of the center of mass of those systems. So you're going to start by taking a system. You can start with any single one, and you're going to sketch that in this little square below. On there, you're going to draw a little dot where you think the center of mass will be. You can do that just by thinking about it, no calculations necessary. And then you're going to draw a line where you're going to set x equals 0 and y equals 0. I've made an example right here where I'm using this system, and there's a little sketch of my x equals 0 and y equals 0 spot. Then you and your group are going to calculate the location of the center of mass of your system. You'll be doing that with the formula for locating the center of mass, the sum of the mass positions divided by the sum of the masses in your system. The first time you go through that, there's a lot of discussion you might have with your group to say, hey, let's make sure we're on the same page as to where we're setting our origin, where the different masses are. And in each system, you measure into the center of mass of this block and this block and this block, and then this block of mass 2m together, and that's my system of mass 5m. Then you'll go through the process and say, oh, the center of mass position must be horizontally at 11.5 centimeters. And for mine, I said, oh, that would be vertically at 0 centimeters, matching with the the axes that I drew on this sketch up here. Then you can actually take your shape and you can balance it. You can say, oh, my system balances just like this. And that is exactly where I thought the center of mass should be. If I thought the center of mass was somewhere else, maybe I thought the center of mass was right in the middle, and it's not balancing at that point, check your calculations again, and you might realize, oh, this system over here has a mass of 2m, or any other mistake you might have made. And then the nice thing about center of mass is you can see it in real life, you can describe it mathematically, and you can describe it with words. It makes sense that the center of mass of this system would be at 11.5 centimeters horizontally, because there's a little more mass on this side, so I'd expect it not to be in the geometric center if it's shifted this way. You're going to do that for 4 different systems today, and you're just going to grab 4 different little cardboard systems. Most of them can balance, but there is one that can't balance because the center of mass lies outside of the actual mass, so there's no place you can put it where it'll balance. So if you get that one, don't freak out, but you can look at it and say, oh, that makes sense because of the shape of this system. Looks like a boomerang. And that's the lab. You guys are going to do awesome today. After you get through the first one, the next 3 kind of all make sense. And if there's any questions, feel free to save them for when I come back next class. Thanks. Bye.